Hello guys, let's prove this standard formula for this integral root a square minus x square by DI method or integration by parts. Now, a square minus x square, you can rewrite it as a minus x into a plus x. However, I've given guys the hint to kind of not do integration by parts, well, by splitting it into this, right? Well, because it gets kind of lengthy and complex, and that's why I given a partial crossing, not a full cross, because you can still get the answer from here, integration by parts, doing this. But if you want to do it, go ahead. I'm not telling you to not do this, but I'm giving you guys the spoilers that you will have to integrate sine inverse of x by a. So if you want, go ahead. And if you also want to try this on your own, please do pause the video, and I'm going to start right now. So if we can't use this, then what do we use? Because for DI method we need two terms. For one we need to differentiate, and for the other we need to integrate. But it's quite simple, because all you need to know is that y is just equals to y into 1. So there we go, because there's always another term lurking around. That is the multiplication of 1. In fact, there is infinitely many multiplications of 1, but for this, let's just multiply it by 1. And now we can use the DI method. So DI plus minus. Since we're trying to integrate this part, that means we cannot put it in the integration part, of course. So we're going to have to differentiate it and integrate 1. So integration of 1 is x, and differentiating a square minus x square whole root, we can write it as a square minus x square to the power 1 half. This power comes down and this power gets minus 1. So we'll have 1 by 2 a square minus x square to the power minus a half. So minus a half, we can put this down. This becomes a square minus x square to the power half, which is simply 1 by 2 root a square minus x square. But don't forget the chain rule, because you'll have to multiply by the derivative of this. So into if you differentiate this, the a square is 0 minus x square's derivative is just 2x. Sorry, yes, 2x. And because of the minus, you have minus 2x. 2 cancels. So you'll get minus x by this thing. So minus x by root a square minus x square. So the first part of the answer is this into that, and then the integration of this into that. So, but before that, what I'm going to do is let I is equals to root a square minus x square. Now this I and this I different, because this is the name of this. We have just put this variable's name. This stands for integration part for the DI method. And here I will be equals to, oh sorry, the integration part, not the term. So that means basically we're trying to find I. We're trying to find the integration. Well, we're not trying to find, we're trying to prove it. So I is equals to first x root a square minus x square minus minus plus. So plus x into x square by root a square minus x square dx. Now, we just need to find the integration of this part. So let's do it right over here. Integration of x square dx by root a square minus x square. You notice I dropped 2 times because I'm trying to make space for left and right. Because what I'm trying to do is, well, trying to introduce this bottom part to the top part, namely within the root. So first we need minus x square, so minus minus. And then we need the a square. Since it's just a constant, let's add it. If we add a square, then we need to subtract a square. And now we can just split these two numerators. So this becomes minus the integration of a square minus x square by its root. Well, just the power, it becomes like y to the power 1 by y to the power half, which is just y to the power 1 minus half, which is the square root of y. So we just get square root of a square minus x square, and minus minus plus, we don't need this bracket, in fact, minus minus plus, so plus a square we can take outside since it's just a constant, dx by root a square minus x square. So I is equals to x root a square minus x square plus or minus root a square minus x square dx, the integration of it, plus a square dx. Well, we can just solve this integral right here. This is simply sine inverse of x by a. If you want to prove it, just let x equals to a sine theta, and very nicely the numerator and denominator will cancel, giving just d theta, which becomes just theta. Theta will be sine inverse x by a. So in fact this is just plus a square sine inverse x by a, and we're almost done. Here we have let I equals to this part, so this part whole thing is in fact I. So we have something something minus I. We can take minus I to the left hand side, so it becomes 2I equals to x root a square minus x square plus a square sine inverse x by a, obviously plus c, c1 c1, and simply we can just divide everything by 2, so this becomes by 2 by 2, and here we have a constant divided by 2, and 2 is just another constant, so there just become another constant, let's say plus c. And here we have proven the standard formula, because I is just integration of root a square minus x square dx. So that is it. And in fact, proving by DI method is so much easier than trigonometric substitution. But if you want a challenge, do try it by trigonometric substitution, and you can watch my video on proving it by trigonometric substitution. And if you learn something new, please like and subscribe. Thank you.